Hello everyone, and welcome to another video. In this video, I'm going to show you how you can do geospatial data joins using both CSV data and your shapefile. So we are going to have like this video split into two videos or two lessons, and so we are supposed to have CSV data merged to our shapefile so that we can create one single shapefile or GeoJSON file that we shall use to create a choropleth map in the upcoming tutorial. So let's get started. And so before that, we will need to actually install Python. If you don't have Python installed in your computer, just go to python.org/download/, then you will come to this page where you will be directed to download the latest version of Python for either Windows or Mac or either Linux. So I'm using Windows and I have already installed Python in my computer. So you just go ahead and download. It's just a direct process to download and install. Then after installing that, you'll also need to download and install Anaconda. I've already installed Anaconda Navigator in my machine. So this is where I am now. After you've installed Anaconda, you will be default base root, or your environment will be on the base or the root, but you can also create a new environment. So to create that, you just need to go to environments, and then you can create you can click on create, and this will create a new environment. You need to choose Python, so we'll choose Python or Python 3. So give it a name, and then you click on Python. After you do that, you need to select to click on create, and that will create a new environment. So I'm using my personal environment which I created. I'm not on the base, which is the root. So here you will also need to install these applications. You can see all applications here. Some of them will be installed automatically, others you may need to install if you like to do more geospatial analysis, so or just data science. Okay, so when you click on Jupyter, what is it? Jupyter Notebook. When you click on launch, this is going to open a Jupyter environment. So something like this, and where you will create your own folders. For my case, I have inside the base folders, I have created a folder called personal work. Inside that, I also have an untitled folder. I just wanted to keep it as untitled. Inside the untitled folder, I have a data folder where I've kept my shapefiles for the area of interest, and also have a population CSV. So this CSV is the one that we are going to merge with our geospatial, our shapefile, so that we come up with one merged data set, which we shall use now to perform the geospatial geospatial data science, and then later on creating a choropleth map. So that is how I've set up my work, and I've created an untitled file here. I can just rename this to GIS analysis, GIS_analysis, like that. Then click on rename. I'm just going to rename my file. Okay, so to test that, we are going to, or to begin with, we are going to import some of the packages that we are supposed to use. I've installed GeoPandas and Pandas. You can come here to your Anaconda Navigator and then go to environments, and environments, you'll see that we have Pandas and GeoPandas. So you can also search GeoPandas like this. You can see that under installed, I have GeoPandas installed. So for your case, maybe you don't have, you need to go to not installed, and when you search GeoPandas, they will be they'll be listed here. So you can click on them, and then you will apply to install. So I like using this method than writing code on pip install GeoPandas or pip install pandas. I love using manual methods of installation because I don't want to mess up some things. Okay, so here on the installed, I have GeoPandas and Pandas installed. Those are the most basic that we shall need to use for this project. Okay, so we are going to import pandas, import pandas as PD. Okay, you can also import GeoPandas. You can also import GeoPandas as GPD. Okay, so I'm going to just copy this Control X, and then put it there. So I'm going to use one cell. Then I'm going to import the regex, because we shall use that to to check or remove some of the values which are not which are like dirty to our data. So we are going to clean that. Then I also need to import JSON, because we are going to convert this data to a JSON format, and so that we can use it for web mapping. So I'm going to click on run. For running your code, you just need to click on run, or you can use Shift Enter on your computer, on your keyboard, and it's going to run your code. Okay, so the next thing is since I already have my data here in the folder, like I have a population, CSV, and the Kenya shapefile there, I'm just going to say like shapefile. I'm going to say shapefile underscore path is equal to, this is going to be equal to inside my data folder, so data slash then ken underscore admin1 dot shp. So if I click on that one, it's going to run. Then I can also now read this file, because now just I've imported to my project, I need to read this file. So I'm going to say like counties underscore shapefile, or GDF is equal to, so this is a GeoDataFrame, is equal to gpd dot read underscore file, and then we are going to read the shapefile path. Okay, so I'm going to click on run. This is going to run my code. So if I want to preview the counties GDF, I'm going to say counties underscore GDF dot info, and then I can see that this is GeoPandas.GeoDataFrame, which is a GeoDataFrame. I have 47 entries. These are rows, so which begins from 0 to 46. Then I have 13 columns. Okay, and these are some of the columns that I have. So I have like the name 1, which is the name of the counties that are found in Kenya. I also have the geometry column. Okay, so I can say counties dot underscore GDF dot head. So I just want to visualize the table for the first 5 rows, and so you can see that these are some of the columns. Okay, so we go ahead and also try to look at the CSV. So I'm going to say CSV underscore path is equal to data slash population. So it is population dot CSV. Click on run. Then I'm going to say population data frame, population underscore data frame is equal to PD. So this is a pandas data frame, not a GPD, because it doesn't have the geometry. Dot read underscore CSV, and this is going to take CSV underscore path, like that. So I click on run, and so this is going to run. To visualize this, I just need to say population underscore PD or underscore DF dot info. So you can repeat the same process, and you can see here that I also have 47 rows from 0 to 46, which means now that we can merge actually these 2 data sets into one data set, because we have the equal entries. Okay, so these are some of the columns. We have the county, total population, male population, female population, households, average household size, land area, population density, population in 2009. Also have population change. Okay, then we also have intersex, population 2019. So in Kenya, they normally do census after every 10 years. So since they began counting people back then in like 1999, 2009, 2019. So the latest data that we have is for 2019. Maybe the country shall also be opting to count people in the next few years, so in 2029. Okay, so to do that, I'll also need to visualize the table. So I'll say population underscore data frame dot head so that I can visualize the first 5 rows in a table. And so you can see this is how the data looks like. So you can see we don't have like IDs or GIDs for this data. So the next thing is we are going to like add the IDs to both data sets so that we can use that ID to merge the data set. Okay. Okay, so to do that, we need to have to sort the shapefile, both the shapefile and the CSV, and then give it an ID that we shall use to like merge the data sets into one GeoDataFrame. So to do that, I'll say counties. I can say counties underscore GDF is equal to counties underscore GDF dot sort values, and we are going to sort this using the county name, so name 1. Then we say dot reset underscore index, and then we say drop is equal to true, like that. So after we do that, I also say counties underscore GDF, and then we add the column, which is the county underscore ID. So this is the ID that we add, and we shall use that to merge both the CSV and the shapefile. So I say dot range, and the range we say from 1 to the length of the number of counties that we have. So I say counties dot counties underscore GDF, and then I'll just say +1. So I'm going to run this, and then I'll repeat the same process for sorting the CSV. So I'll say population df population underscore df is equal to population df is equal to population underscore df. Then I say dot sort underscore values, and then I'm going to pick the name of the county, which is county, and then I'll just say dot reset underscore index dot reset index, and then drop is going to be equal to true. Okay, then I'll go ahead and say now populations. I'm going to add the ID, so population df, and then I say county underscore ID. Then we say this is going to be equal to from range, and the range is going to start from 1 to the length of the number of counties that we have in our DF. So I say length, and then we say population DF. So I say population underscore DF, like that. And so I'm going to run this also. Now here I'll need to say now +1. Okay, so I'm going to run that. Then the next thing is now to merge. So I can write here a comment and say merge using the CSV count ID. So this is what we are using to merge, because now we have both of the county ID on both data sets. So here I can just say merge using merge using this county underscore ID. Okay, so here I will say merged underscore GeoDataFrame GDF is equal to, now we take the counties underscore GDF, and then we say dot merge. We are going to merge population underscore DF. Okay, population DF, and then I say left is equal to left underscore on is equal to now the county ID, like that, and right on. So I say right underscore on is also going to be the county underscore ID, like that. So how we are going to use the left method. So I say how is going to be left. So if I run this, and then I just say merged underscore GDF dot info click on run, and then you can see that we have, this is a GeoDataFrame that has 47 entries, which is from 0 to 46, and now the total number of columns is 25. So you can see all those, the one that we have. So we have counties, county ID for our CSV, and then we have the county, the total population, the female, male population, households, and whatever that the columns that were in our CSV dataset. Okay, so the next thing is now to clean up the numeric columns in our CSV. For example, if I just say, instead of doing this info, I can say merge df.head, so that I just show you what I mean. So you can see this kind of data is like in strings. You can see here 666, then we have a comma 763, 336, comma 322. So these things we cannot use to display in GeoJSON format. That's why we need to clean up, so that we just remain with if it is 875, 689, there is no comma inside that data. Okay, so you can either comment that or you can leave it. So here on the new cell, I'm going to clean up the columns that I want, especially in the CSV dataset. So I'll say numeric underscore columns is equal to, this is a list of columns. So the first column is population underscore 2019. So it is good that I just do copy these things instead of typing in, because I might just mess up with the typo. So scroll down and then just paste it here. Then we put a comma. Then we move to the next one is, I think instead of scrolling, I will just do this. I'll just say info, so that I bring back the columns closer to the new cell that I'm using. So then I'm going to copy the population for male, and then I just going to paste it inside there like that. And so I need to put a comma there. Then I need also the female population. Female populations, I'm going to copy female population. And remember, this is population and not population. So just so that you know that. So I'm going to copy this one also. I'm going to paste it there. I move to the next one is households. I'm going to copy the households, Control C. And then I'm going to say Control V. Households. I'm going to put a comma there. I move to the next one is average household size. Control C then. I'm going to paste it there like that. So we're going to repeat this process for the rest of the columns. I need the land area. Oops. Just need to paste the land area. I also need to paste in the population density. Population density. I need to put a column, not a column, but a comma there, because this is a list. So I need also population in 2009. Population 2009. Control V, comma. I also need population change. Population change. Then I also need, the last one is the intersex, population 2019. So I'm going to copy this one and then paste it here like that. So the next thing is that I'm going to write a function that is going to clean up these columns. So down here, I'm just going to write a function. So I'll say define a function called clean underscore numeric. And this is going to check in the values or the value. And then I'm going to say if pd dot is null value, we are going to return. So if it is not null, we are going to return none. Okay, then I'm going to check say the value is equal to. So if it is not that, then we now start to clean up our value dot strip. Then, for example, as I just mentioned, you can see here in the df, so I can bring the head back so that I show you something. Looking at this, you can see we have 666,763,336,332. We also have other columns or other values that are not with commas, but they have like parentheses. So that is also what we are going to clean up from our data set. Okay, so I'll go down here and say that if the value, if value dot starts with, so if it starts with this, then I put in this one here. So if it starts with that and the value ends with, so the value dot ends with this. So if the value starts with that and ends with this, which means like we are converting, let's say if we have a number like 1 2 3 4 5 looking like this in our data set, for example, so we are going to convert that to something like looks like 1 2 3 4 5. Okay, so that is what it is doing here. So we say that if it begins with this, so if it has this one and ends with this, we are going to remove that. Okay, so I think I'll just need to remove one parenthesis there. So this one goes with this, then ends with this one. So if that is the case, we're going to say value will be equal to then value 1 from 1 to -1. Then we are going to also remove commas, as I mentioned. So this is a comment. So we are also going to say, that value is equal to the regex that we imported above. So this one here. So you're going to say value is equal to the regex dot sub. Then we just look inside the strings like this. So if it has things like this, commas, and also some foreign characters like that, like that. So you're going to say the value. So we're going to look if there are any errors. So I'm going to say try and return the float of the value. Then you can say except. So if there is any error, we are going to run the value error. Then now we can say return none. Okay, now if that's going to be the case, we can go ahead and say for columns in numeric columns that we have declared above, say if column in population underscore df dot columns, then we say population underscore df, we take the column Then we say is equal to now population. So we add that column. We say population underscore df column. Then we say dot apply. Then we can say now clean numeric. So we call in the function. So our function is clean numerics, which is here. So we are going to add that if the column is actually inside the our population df dot columns. So if it is there, we are going to now add that column. So we are going, it's like we are going to reiterate through the columns and replace whatever the columns that we had, because now we have corrected the values for each of these columns that we have. So we just check if these columns actually exist in our previous population df, then we replace it with the new corrected data values. So I'm going to run this function. Then it says invalid syntax. We have this one here. So if value string is equal to need to put this one there. Okay, so the function has successfully executed. We are going now to join the datasets using our county ID. So for that case, I'm just going to say that GDF is equal to the counties underscore GDF dot merge. We are going to merge the population underscore df, and on the county ID, county underscore ID, and then we're also going to say how this is going to be on left, and the suffixes is going to be equal to the shapefiles. So we put the shapefiles like this. So underscore shp, underscore shp, and then underscore csv. So we are going to merge these datasets into one GeoDataFrame. So the counties GDF that we have and the population DF, which is now a corrected population DF up here. So I'm going to click on run. And now the next thing is I'm going to fix the invalid geometries. Remember that our geometries may also have some overlap. Like if you have ever interacted with geospatial data, I think you know that. Like if you zoom in where the two intersects, the two boundaries intersect, for example, like we have different counties, they are intersecting at somewhere, you find that those two lines are overlapping each other, so there is some buffer or some space in between. So what we are going to do is that we are going to remove that so that it just become one line, so that it doesn't create the GeoJSON export does not fail to export the GeoJSON, because it is very, very strict when it comes to such gaps in between the geospatial data. So I'm going to say GDF is equal to the GDF that we have above dot reset underscore values, just as we did. Now we need to reset the index, and then we are going to say drop is equal to true, like that. Then I'm going to say that GDF dot we add the ID first, so we need to add the ID. No, we are I don't think if we need to do this one here right now. We need to, this is for adding a new column for GID. I don't think we need that one now, I think later on. So we need just to fix the invalid geometries first. So I'm going to say GDF. Then inside that, we are going to pick the geometry column. Remember, that is what we are looking for, is equal to GDF geometry dot buffer we set to 0. So we're going to set buffer is equal to 0, and then you can also say GDF is equal to GDF, then GDF dot is underscore valid. So we are going to confirm if it is valid, and then we're also going to check if the geometry is empty. So we say GDF is equal to GDF, then GDF dot geometry geometry like that. Then we say dot is underscore empty. Then you can also say GDF is equal to GDF, our GeoDataFrame. Then you say GDF dot geometry dot not null, like that. So I'm going to run that, and the next thing is now to add the geometry ID. If you want, you can also confirm if this one has been corrected. So you can say something like the length. You want to confirm the remaining features, so you can say since we have corrected, that means we have dropped some, we have edited some of the features. So you can say remaining features after geometry fix. Then we call the length of the remaining GDF like that. So if you print, you can see that remaining features after geometry fix is 47. So it means that maybe there wasn't so much errors in our rows, so we still remain with 47. Now the next thing is that we are going to add a geometry ID that we shall use to reference our data in when we shall be creating our choropleth map using React Leaflet. So it is good that we have the GID. It is very, very important because now it is very unique to each of the rows that we have. So for that case, I'm going to say GDF is equal to now GDF dot reset underscore index, and then we are going to say drop is equal to true. Drop is equal to true. Then I can say GDF, then we add the GID column, GID, and we say this is going to be equal to GDF dot index. So we are going to put this at the first index 1. Okay, then I can say now columns, or what you can do is you can run this, then we can say columns is equal to now our GID, then we say if columns, for columns in our GDF dot columns if column is not GID, so if the column is not the GID column that we've just created, so we are going to add that column. Otherwise, if it exists, then it means that we are not going to replace it. So I can say GDF is equal to now GDF, and then we pass in the columns. Then we can also print. We say print. I'm going to print the GDF like this. Then I put the GID, the county. I'm going to print the GID, the county underscore ID, and also the name of the county. So name underscore 1. Remember that from our GeoDataFrame. Then I'm going to say dot head like that. So click on run that. Or then it says that data frame object has no attribute head. Oops, it's supposed to be lowercase head like that. So you can see that we have the GID, we have the county ID, I also have the name of the county, so you have the names of the counties there that are listed. So after that, we are going to force this to like take the 4326 CRS. So if I just come up here and try to look at the information that we have, I think we didn't get the CRS, but you're going to say GDF is equal to GDF dot to underscore CRS. So make sure that you are going to use the EPSG 4326. So this is like the World Geographic Coordinates Reference System. So I'm going to run that. And now the next thing is that I'm going to now save the GeoJSON file, or you can still do GDF dot info and run. Then you can see that we have all these rows, and this is a GeoDataFrame. Okay, so what I can do now, I'm going to save this GeoJSON file into my directory here. So I also need to define an output. So I'll say output underscore GeoJSON is equal to, then I need to pass in the folder that I would like to save my work. Okay, so I can just say like I want it to be inside my data folder. I can create a new folder here. So inside my data folder, I can create a new folder. Do I need to create a new folder? Let me just say data, and then I can pass the name. I can say counties underscore something like ready dot GeoJSON. Then I click on run. Now I'm going now to import this or save that to file. So what I'll do, I'll just say GDF is equal to GDF dot to file to underscore file, and I'm going to pass in the output underscore GeoJSON. Okay. Oops. I'll say the strings, then the encoding. Encoding is going to be the UTF-8 as F, like that. So GDF underscore file output. No, I don't think I need to write this one first. Let me just make some correction here. So GDF dot to file. So we are going to save inside our folder that I've just created here. Then I'll need the driver to be GeoJSON. Yes, this is what I was forgetting. So driver is equal to GeoJSON, like that. So I'm going to run this. I'm going to run that. Then I'll say with open. Then we are going to pass in the output underscore GeoJSON, then the string as R, like that. Then encoding is going to be the UTF-8, then I can say as F. Then I say GeoJSON is equal to JSON. Remember we imported JSON above, dot load. Okay, F. So the file. So we are going to load the file. So the F stands for the file. And so I'll say GeoJSON dot pop. Then I'll say CRS none. Then down here I'll say with open again. Think I'm tired of typing all this. I can just copy and paste it here. Then I'll say that one. Then I can say encoding is equal to UTF-8, then as file. Then I can go ahead and say JSON.dump JSON GeoJSON file as that. Okay, then I can go ahead and also print. So if this function is successful, I'll just say something like GeoJSON successfully created. Yeah, can just say like something like that. So GeoJSON successfully created. So I'm going to run this, and hopefully this is going to write to our file, our folder, the GeoJSON file. So it's going to take some few minutes. Then you can see it says GeoJSON successfully created. So now if we go here, you can see that we have our counties ready.geojson. So how do we know that this is actually true? We need to create like something like a web map here in the notebook using what do we use, Shapely or Folium? We can use Folium to display our GeoJSON file to an interactive web map. Okay, so here I'm just going to say import. Now we need to install first, so I'm going to say pip. I'm going to say pip install Folium. Pip install Folium. Since I already have GeoPandas installed, so I don't need to install GeoPandas. I'm going to click on run, and this is going to install Folium. So let's just give it some few minutes. Then it says that everything is successful, but you may need to restart the kernel to use updated packages. So here I'm just going to the kernel, and then I'll say restart kernel. Click on restart. So the kernel is shutting down. Then it will restart automatically. Still loading. Yeah, then we have our kernel there. Yes, so we can go ahead and now create a new cell here. So I'll say import. Since we already imported GeoPandas, I'll just say import Folium. Click on run. Then I'm going to load the GeoJSON that we just created. So I will say GDF is equal to GPD, which is the geopandas.read underscore file. And we are going to read whatever we have inside our data folder. And then we got the new counties.geojson. I hope so. Let's just confirm. So you have counties ready, counties underscore ready GeoJSON. You can click on that. GPD is not defined, so we shall need to rerun this. I'm just going to comment this one here, and then I'll say import pandas, import GeoPandas as GPD like that. Click on run. I'm going to rerun. Now we have our GeoDataFrame. Let me just plug in my computer to power. Okay, so we can continue. It is not it's not charging. Okay, so here I'll need to do something like gdf.info. We still get our GeoDataFrame like that. So I'll go ahead and say I'll need to center the map now. So I'll say center is equal to, then we say gdf.geometry.centroid our longitude dot mean, and then I can duplicate this and say x. Okay, then down here I can just print out some things to verify that I have the correct crs.crs, and I also have no null values. So I'll say gdf dot is underscore valid dot all, like that. Then I'll also look at the length of my gdf. So I'll say length of the gdf like that. Click on run. gdf, perhaps you forgot a comma, dot all. Yeah, I needed a comma here, so click on run. Print. Oops. Print. Okay, so the CRS is 4326, and then we have true data frame. So our boundaries, or our GeoDataFrame boundaries, are true. Then the length is 47. So we have 47 counties, which are the rows. So I'm going to now create my map. So I will say my map is equal to folium. My computer is not charging. Now that one is good. So folium, and so folium dot map, and we are going to pass in the location. So location will be equal to the center, so the x and y. The zoom level, zoom start will be 6, and then the tiles we are going to use OpenStreetMap. So OpenStreetMap, like that. So I'm going to click on run, and then I'm going to add the GeoJSON layer to my folium map. So I'll say folium dot GeoJSON, then we pass in our GeoDataFrame like that, and the name is going to be, you can say like Kenya counties, like that. Kenya counties. And then tooltip. The tooltip is like when you hover over the map, you see a pop-up. So this is not going to be just a pop-up, but a tooltip. So a tooltip is like an advanced pop-up, just to say, but you'll see when we finish creating the map. So I'll say tooltip will be the folium.geojson pop-up. So tools, tooltip, GeoJSON, supposed to be folium GeoJSON tooltip. Tooltip. Then I'll say fields. is going to be equal to now GID. You remember the GID that we created? Then we need the name of the county, name 1, and we also need the total population. Total underscore population, total population 2019. Aliases. So the fields, these are the things that are going to appear in our pop-up. Okay, so I'll go ahead and say aliases. So if they are not there, we can use this one, GID, 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 county. You remember we have county also, and you also have the population 2019. Population 2019. So these are just columns in our data set. Okay, then I'll say localize is equal to true. Then inside our GeoJSON file, we shall say now the pop-up is equal to folium dot GeoJSON pop-up, GeoJSON pop-up, and inside we are going to have fields as GID, like that, and the name of the county as name 1. Then aliases is going to be, this one is supposed to be equals to, always used to JavaScript, so I say GID and then the county name, like that. So after we have performed all those processes, we add everything to map. So I say add to, then we add to my map, my underscore map. Then after that, we just need to say folium dot layer control So we are going to also add some layers control. So I say add to underscore my map. Then we can call my map down here. So I'm going to click on that. It says module folium has no attribute GeoJSON tooltip. Oops, what am I doing? GeoJSON tooltip. This is an error there. Click on run. And now hopefully this is going to load our interactive web map, which we just want to confirm. Then boom, so we got our GeoJSON web map here, displaying the data that we just joined, the CSV and the shapefile that we got. So if you click there, you can see that we have the GID as 40 and the county name is like Tana River. But when you hover over the map, you can see that we have a tooltip. So this is what is called a tooltip, which changes depending on the direction of the map. So this is it. We have managed to import, to join our datasets, our CSV dataset and the shapefile that we have for our GeoDataFrame. And we have come up with our GeoJSON dataset that we can use to now create a choropleth map in the upcoming videos. So thank you for watching. I hope you have learned a lot from this tutorial, and I hope you will also do practice to gain more knowledge on geospatial data analysis. I hope you've enjoyed. Make sure to subscribe to the channel, and I'll see you in the next video, which will be about creating a choropleth map using this GeoJSON data that we have just combined with the CSV dataset. So see you then. Make sure to subscribe to the channel, and also if you have something, you can also write the comments. I'll be going through into the comment section to answer all the questions that you guys may have. So also make sure to share with others so that we all prosper in the field of geospatial data science and web mapping.